Hey guys, welcome to question FM279 of the Further Maths Fortify study guide. This question reads, the diagram below shows a network of tunnels between 6 bases at a paintball arena. K, L, M, N, O, and P. The numbers indicate the distances in meters that are travelled by tunnel to connected bases. Question A starts with, Ruby follows an Eulerian trail through this network of tunnels. Part I asks us, write down the names of the bases at the start and end of Ruby's trail. So what we're going to start off by doing is just giving each of our vertices their degree. So K has a degree of 4, L has a degree of 3, M has a degree of 4, N has a degree of 4, O has a degree of 3, and P has a degree of 2. Now, by now you guys should be starting to learn that if we're going to have an Eulerian trail in a circuit, we are looking at all of our vertices being even except for 2. And those 2 odd vertices, in this case L and O, they're going to be our start and end points. So if we start at L, we will end at O, and if we start at O, we will end at L. Cool. Part I then goes on to say, what distance did she travel? So this really is just a matter of adding all of the edges, all the weights of the edges that we see here together, because of course if she's following an Eulerian trail, it's not necessary for us to know what direction she took or what trail she took. We just need to add all of the edges together because of course all the edges are used in an Eulerian trail. So we can just start by adding all the outside and then slowly working to the inside. So it might look like this. So we could say 140 plus 90 plus 130, plus 110, plus 70, plus 110, plus 60, plus 70, plus 100, plus 80, and then adding all of those together should equal 960 meters. Now, it is important that we put this answer in meters because the question says, what distance did she travel? So writing just 960 isn't sufficient because it hasn't been implied that the answer, well, it might have been implied, but it's not strictly saying that the answer should be in meters. So it's important to give this meters unit so that whoever's marking the question knows that you know the exact distance and what unit it's being measured in. Question B says, Maddie will follow a Hamiltonian path from base P to base L. What is the shortest distance she can travel? So she's going to be traveling from P to L. So we know that we're starting at P. Our next best move is probably going to be to move towards this M rather than moving down to O. From here, we don't want to move towards L yet because we're going to finish there. And we know that she's following a Hamiltonian path, so we can't go to a vertex and then come back to it, which means that we're going to go down to N. From here, we obviously don't want to go down to K because then we trap ourselves with O, like we can't get out of O and then back to L, so we're going to go from N down to O. From O, we're going to travel up to K, and we're finally going to finish off at L. So putting the weights together that it would take to get to each of these vertices in that order would look like this, which when we add it all together, ends up equaling 400 meters. Once again, it's important that we put this meters symbol in, or you can write meters, whatever it is that shows that you're using a unit here, because this question also says what is the shortest distance she can travel. It doesn't say what is the shortest distance she can travel in meters. It doesn't mention meters in the question, so we need to give that unit because they've just asked for a distance. Finally, we're given a little bit more information. We're told that the tunnel between base O and base N is closed off. So that's this guy here, disappears from the map. If one other tunnel is closed off from the network, Coco will be able to follow an Eulerian circuit through the network of tunnels. C asks which other tunnel should be removed. In the boxes below, write down the pair of bases that this tunnel connects. Now, what also happens when we remove this edge is the degrees of N and O change. O now has a degree of 2 and N now has a degree of 3. In order for an Eulerian circuit to exist within our network, all of our vertices must be of even degree. The two vertices that are not of even degree are L and N, which means if we were to remove the edge between them, it would turn each of them from being odd to even. And now we would be able to perform an Eulerian circuit here. So for example, we could move around like this and then move all the way around, finishing and starting at K. Cool. That answers all of those questions, guys. So if you have any questions for us, please leave them in the comments below. Otherwise, we'll see you in the next video.